Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we go through revision for the final test for Year 8 this year. So it's on probability and geometry. So I'll start with probability and I'll try and keep this video shorter so I won't go through everything in its minute detail. If I skip over something you don't understand, please let me know. Please email me. So as I said, we will start off with probability. So hopefully you know that probability is the maths of giving an event a number between 0 and 1 to indicate how likely it is to occur. So when I write this weird thing with a lot of mathematical symbols, you read that as the probability of an event is between and including 0 and 1. So if the probability of the event is close to 1, it's likely that it will happen. If it's close to 0, it's unlikely that it will happen. Probability of 1 means certain, and probability of 0 means impossible. So the way that we actually figure out which number to give the event, what its probability is this formula. So probability of an event equals the number of ways it can occur over the total number of outcomes. So NS means number of events in the sample space, okay? So for example, let's go with an example that I pick a card from a deck. So there are 52 cards in a normal deck. So the probability that I get, say, a red card, there are 26 of those out of 52, which is the same as a half. Okay, and that makes sense because in a deck you have red cards, you have black cards, two options. So the probability I get an ace, for example, so there are 4 aces in a deck: ace of hearts, ace of spades, ace of clubs, ace of diamonds. There's 4 out of the 52. There are 52 cards in total, and that just simplifies to 1 over 13. So it really does not matter whether, when you're asked for the probability of something, you give a decimal or a fraction or a percentage. Either of those is fine. Just make sure, as I've said heaps of times before, that if I say what is the probability of blah, 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 you give me a number between and including 0 and 1. So don't say the probability of ace is 4 because there are 4 aces, because that doesn't make sense. That's obviously more than 1. Okay? So remember, we also talked about complements. So the complement of an event is just that event not happening. So for example, the event that I pick a red card out of a deck, the complement of that is that I pick a card that's not red, i.e. I pick a card that's black. The event that I pick an ace out of a deck of cards, the complement of that event is that I pick a card that's not an ace. So the rule is that probabilities always add to 1 in exactly the same way that percentages add to 100%, because 1 and 100% are exactly the same number. So if you know the probability, say that I get an ace, the probability that I don't get an ace, so that's what this little dash means here, not, is just 1 minus the probability I do get an ace. So 1 minus the probability I do get an ace, which is 12 over 13. That makes sense. So if the probability it rains today is 0.2, the probability it doesn't rain today is 0.8. If the probability my team wins footy on the weekend is 7 over 10, the probability my team doesn't win footy is 3 over 10 because they add to 1. It's important, remember, we've got to make sure that complement is just the event not happening. So for example, the event that you get an A in your maths test, the complement of that isn't that you get a B. The complement of you getting an A is you don't get an A. So you could get a B, C, D, or E. Okay, so just make sure we understand that. Complement is just the event not occurring, and the probability that an event does not happen is just 1 minus the probability that it does happen. Okay, we're going to look at the other things we did in probability now: Venn diagrams and two-way tables. Okay, I'm going to use this example to show you how to use two-way tables and Venn diagrams. So let's say we have a group of 50 iPhones. We tested them for their faults. We're interested in whether they had faulty cameras, faulty batteries, both or neither. We found 30 had no faults at all, 15 had faulty batteries, and 9 had faulty cameras. And we're going to use this to answer some probability questions. So you're probably thinking, well, what does this possibly have to do with Venn diagrams and two-way tables? How does that relate to iPhones? Well, the point of two-way tables and Venn diagrams is to display information in a convenient way to help us with probability calculations. We use Venn diagrams and two-way tables when we have information about two sets. So here we have two sets. We're looking at iPhones that have faulty batteries, so that's one set, and faulty cameras, that's another set. So two sets, straight away I know I am going to use two-way tables and Venn diagrams to make the information visible in a convenient way. So that's what I'm going to do here. Let's start off with the Venn diagram. So they all look pretty much the same. We're only looking at two sets. So a rectangle and two circles, one for each set. Okay? So the two sets here, we've got iPhones that have faulty batteries. That's what I mean by bat, and then cam for faulty cameras. And there are 4 numbers that go in a Venn diagram. 3 inside the components of the circle and 1 outside. So the number that goes here, it's in the battery circle, but not the camera circle. So that's how many iPhones had a faulty battery, but not a faulty camera. This is faulty camera, but not a faulty battery, both and neither. So there's 4 options for an iPhone. You can have neither fault, both faults, just a battery fault, or just a camera fault. So we're going to put those 4 options into the Venn diagram. What I'll do is first put the numbers in the Venn diagram and then show you how the two-way table would look. So hopefully you are sitting there confused. You're thinking, but wait a minute, 30 plus 15 plus 9, that equals 54. How does that possibly work when there were only 50 to begin with? Well, I can tell you it does work. And the way it works, it means we have 4 too many. We've double counted 4. We counted 4 in this set, but also in this set. That means 4, the number by which we overcounted, 4 goes in the middle. It's both. There were 4 iPhones that had both a battery fault and a camera fault. So we were told that 15 had faulty batteries. So I want 15 in this circle. I've already got 4 inside this circle, so I need 11 more. So 11 goes there, and there are 15 in the battery circle. Similarly, I want 9 in the camera circle. I've already got 4, so I put a 5 there. And now there are 9 inside the camera circle. And the number that's neither just goes outside, so that's 30. So hopefully now you see 30 plus 5 plus 4 plus 11 does equal 50. So the numbers in your Venn diagram and two-way table should add up to 50. So I know I've done something right. So a two-way table does the same thing as a Venn diagram. It's just a different way to do it. You do need to know both for the test. So we have 2 ways corresponding to the 2 sets. So we have battery fault, and remember the dash means not, so this is not a battery fault. Then camera fault, not a camera fault. And in two-way tables, we usually have a row and column for totals. Okay, so the 4 numbers that went in the Venn diagram correspond to the 4 numbers that go into these 4 boxes. Okay, so we'll start off with this first box here. So that is in the camera row and the battery column. So it's the number that have a camera fault and a battery fault. So that's just 4. It's just this number here. Then this box next to it, they have a camera fault but not a battery fault. So that's this number here, 5. Here we're in the battery column. So we're in this column, meaning they do have a battery fault, but we're in this row, so they don't have a camera fault. That's 11, and then this is neither, not battery, not camera. So I just add up the totals. 4 plus 11 is 15. And of course, 5 and 30 gives you 35, and we add up the others as well. These 2 numbers and these 2 numbers should add up to the same thing, and they do, which is 50, the total number of iPhones in this case. So you can see that pretty much the same information is displayed in both the Venn diagram and also the two-way table. And now that we have that information, we can use it to answer some probability questions. So firstly, what's the probability that an iPhone at random has a faulty camera and a faulty battery? So we just use the formula that I went through before. Probability of an event, number of ways it can occur, over total number of outcomes. So for A, there are 4 iPhones that we can pick, 4 ways it can occur out of 50 in total, or 2 over 25. Again, putting it as a decimal is fine. So camera or a faulty battery. So in maths, when we say like A or B, we mean A or B or both. So what I really mean here is, what is the probability that an iPhone selected at random has a faulty camera or a faulty battery, or both? So in the Venn diagram, we're looking at these 3 numbers, because that includes all the batteries and all the cameras, and in the two-way table, these 3 numbers. So 5 plus 4 plus 11 is 20. So it's 20 out of 50, or 2 over 5, okay? Now, if we're looking at a faulty camera or battery, but not both, we don't include the middle number here. So we don't want to include these because these are both. So we include the 11 that have a faulty battery only and the 5 that have a faulty camera only. So there's 16 in total out of 50, or 8 over 25. How easy is that? Now we'll go through the geometry section. So in the geometry section of this course, we were primarily concerned with congruent. So 2 shapes are said to be congruent if basically they're the same shape. So they'll be the same shape and size. One will be a reflection. Remember, that's a flip, rotation, which is a turn, or translation, which is a slide of the other, okay? And they have to be identical shapes to be congruent. It basically means if you have 2 congruent shapes, you can take one, rotate it, translate it, or reflect it, or do a combination of these, and it will fit exactly, perfectly on top of the other shape. So for example, I know I'm a bad drawer, but let's say both of these shapes are squares, and this one's going to have side length 2 centimeters, and this one is going to have side length 3 centimeters. So these shapes here, even though they're both squares, are not congruent because one's bigger than the other. So 2 shapes are congruent if they have all side lengths the same, pairs of corresponding sides are equal, and also pairs of corresponding angles are equal. So in this diagram here, pairs of corresponding angles are equal, but the pairs of corresponding sides are not equal. They can't be congruent because one shape is larger than the other. So just make sure you understand what a reflection, rotation, and translation is, and make sure that you understand that 2 shapes are congruent if they have the same side lengths, same set of angles, okay? So we looked specifically at congruent triangles because they have special properties, which I'll now go through. So what's special about triangles is that if you want to determine whether or not 2 triangles are congruent, you don't need to check every pair of angles and every pair of sides. You just need to apply one of 4 tests, or see if you can. So the tests we went through, SSS, SAS, AAS, and RHS. So in all of these, S means side. More accurately, it means a pair of equal sides between the 2 triangles. And A means a pair of equal angles. So the R means right angle. That's just in the last test. So it has to be a right angle, can't just be any angle. And the H stands for hypotenuse, which is the longest side in a right angled triangle. So these tests, if I can apply any of them, if any of them hold, then the 2 triangles are congruent. So for example, the first test means side, side, side. It means that if you have 2 triangles and there are 3 pairs of equal sides between those 2 triangles, then the 2 triangles are congruent. It means that if there are 3 pairs of equal sides, then there will be 3 pairs of equal angles. I don't even need to check the angles. AAS means there are 2 pairs of equal angles and a pair of equal sides, okay? It doesn't really matter whether you call this ASA or SAA. It can be any two pairs of angles and a pair of equal sides. And as you probably guessed from my explanation just then, this means right hypotenuse and side. So if you have two right angled triangles and their hypotenuses are equal and another pair of sides is equal, then they will be congruent. The trickiest one is this one, SAS, because it has to be two pairs of sides that are equal and the angle between them that's equal. So it can't just be any angle that's equal. And I'll go through examples of each of these. So for example, let's say I have two triangles, and please excuse my poor drawings. So let's say we have 3, 3.5, and 4, and this one, 3, 3.5, and 4. These two triangles are congruent by the SSS test. I don't need to check this angle and this angle. I know that they're going to be equal because of the SSS test. These two triangles are congruent. It also means this angle and this angle will be equal. It also means that this angle and this angle will be equal. Okay, so that's the SSS test. So an example of the SAS test, so you might have two triangles here. We might say this is 6 and 6, and it has to be this angle between them. If I have an example where, let's say I have triangles like this, and I tell you that this angle and this angle are equal, and I have, two pairs of equal sides, I can't use any of the tests and say that these two are congruent. So the reason is I have two pairs of equal sides, but not the angle between them. So I don't have enough information to say whether these two triangles are congruent. I can't say they're definitely not congruent, I just don't have enough information. So the AAS, it can be any two angles and sides. So let's say I have a triangle like this, and I'm telling you, by the way, in case you don't know, the fact that there's the same dot here and here means these two angles are equal. And let's just say that this side here was 8. So I have two angles, two pairs of equal angles, and one pair of equal sides. That's the AAS test. So please don't think that whenever you have a right angle in a triangle, it has to be RHS. It could be SAS, or it could be AAS, as I just showed you. The RHS test does have to be a right angled triangle. So in its example like this, and this will get confusing. So let's say I say that this is, say, 14 and 15. The thing here is that I have two pairs of sides. So I have two pairs of equal sides and an equal angle. It's not the angle in between. So RHS is the only time you can have two pairs of equal sides and not the angle in between. It has to be a right angled triangle. The reason for this is because I can use Pythagoras, and the third sides will also be equal, okay? So these two triangles that I've just drawn here, they are congruent by the RHS test. So please make sure you know all of these tests thoroughly. Now I'm going to just go through examples of how you might prove that two triangles are congruent. So it's important we understand the difference in the kinds of questions that you might be asked. So if I say to you which test shows that these two triangles are congruent, you can just write, SSS, SAS, AAS, whatever you want. However, if I ask you to prove that two triangles are congruent, you need to go through and give me reasons. All the proof involve three things, and those things are either sides or angles, some combination. Might be three sides or two angles and a side or whatever. What you have to do is you have to show, why the two sides are equal, or explain why the two angles are equal. You need to have three reasons, and then we conclude. I'll show you an example of this. So I'm going to go and formally prove that the two triangles in this diagram are congruent to each other. So what I need to do is I need to first figure out how I'm going to do this, which test I'm going to use. So hopefully you can see that I'm going to have a proof involving these two sides being equal, this side being equal because it's in both triangles, and this angle being equal. So I'm going to use the SAS test. So what I need to do is I need to say why the first pair of sides is equal, why the second pair of sides is equal, and then why the pair of angles is equal. Let's go ahead and do that. So first off, we know that this side and this side are equal because they both have the 1 dash, means they're the same length. So I say AB is equal to CD, and the reason in brackets I give is just given. I was told that. So that's like an S, okay? So then the next one I'm going to do is this angle and this angle. Again, it's just told to me. So this angle here, it happens to occur at B, so B goes in the middle. So I call it angle ABC. That is equal to this angle, which is angle BCD. Again, that was just told to me, given. So that's my A. So I've got 2 things that I've shown, 2 pairs of equal things. I need one more, and that's going to be a side. So you can see that BC actually occurs in both triangles. So if this line is 5 centimeters in the first triangle, it's going to be 5 centimeters in the second triangle. It has to be equal. So look out for those. We call them common sides. So I just say BC is common. So now I've shown that there is 2 pairs of equal sides and a pair of equal angles. So I've proved that they're congruent using the SAS test. I just need a concluding statement. Therefore, triangle ABC is congruent to, that's what the 3 lines mean, triangle. Now I have to line up the vertices, okay? So A corresponds to D, so I write D first because I wrote A first. Now B here actually corresponds to C in the other triangle. So I write C second and B third, and the reason in brackets is SAS. So hopefully you can see that triangle ABC has just been rotated to get triangle BCD. So one of them is just a rotation of the other, that's why they're congruent. We'll now look at a higher example. So I'm now going to prove that the 2 triangles in this diagram are congruent, the top triangle and the bottom triangle. So as with the previous example, I need 3 things. A combination of sides and angles. I need to say why they're equal. So this symbol here and this symbol here mean the 2 lines are parallel. It doesn't mean that they are necessarily equal. So I can't use those 2 sides in my proof, but hopefully whenever you see parallel lines, your eyes light up and you think, oh cool, I can use alternate angles or perhaps corresponding angles. So remember the Z shape is alternate. So if I put the Z there, this angle and this angle will be equal because they're alternate and I have parallel lines. Similarly, this and this angle, both of them, they make Z shape and they will be equal. The other pair of angles you can use in the middle, I have 2 angles that are vertically opposite. So this angle and this angle here will also be equal because they're vertically opposite. So I've got 1 pair of equal sides, and I can use 2 out of those 3 pairs of angles that I just spoke about, okay? So I'll start off by using the sides. So I'm going to say DC equals CB, and that's just given to us. We were told that. So that's the only pair of equal sides I have. I'll now use the 2 angles marked in red. So this angle here is angle DCE, and that is equal to angle here, which is ACB. And the reason, I'm just going to abbreviate it, they are vertically opposite. And now I'll use this angle and this angle, which I told you they were alternate. So the way I write that, angle DEC, which is this one here, is equal to this one, which is angle CAB. And they are alternate angles, and I have parallel lines. So therefore, the bottom triangle, which I'll call DCE, is congruent to the top one. Now D, this angle here, is equal to this angle here. So D corresponds to B, C corresponds to itself, and E corresponds to A. The test, as I mentioned before, is AAS. Okay? So that means I can use this to find values of pronumerals. So if I told you that this shape here was 6 centimeters, and I said, what's X? X would also be 6 centimeters. It means if this angle here, let's say it was 50 degrees, this angle here would also be 50 degrees. So we can use congruence quite easily to find unknown sides and unknown lengths. It's as easy as that. All right, we're now going to look at a proof involving a quadrilateral. So now we're going to look at using congruent triangles to establish properties of a quadrilateral. So of course, ACDB is a quadrilateral because it has 4 sides. You probably know that it's a parallelogram, and that's because we have 2 pairs of parallel lines, okay? So I'm going to show that opposite angles are equal in this shape. Now, hopefully, you can see that by dividing it into 2 triangles like I have, if I can prove that they are congruent, then I can show that these 2 angles will be equal and these 2 angles will be equal. Okay, so that's my goal here. Show that the 2 triangles are congruent, and then use the fact that corresponding angles in congruent triangles are equal. Let's get to the proof first. So I know that this angle here and this angle here are equal. Now the reason they're equal is because I have parallel lines and they are alternate, just like in the last example. So ABC is equal to angle BCD, and the reason they are alternate, okay? I actually have another pair of alternate angles. So because this line and this line are both parallel, I have another Z shape there and there. So those 2 angles are equal. So this one here, I'm going to call angle ACB. Again, the angle is at vertex C, so C has to be in the middle, and that is equal to angle CBD. B has to be in the middle because that's where the angle is, and they're also alternate. Now remember, I can't prove that 2 triangles are congruent just based on angles alone. What I have to do is have at least 1 pair of sides, and I can do that easily because I know that CB is in both triangles. So I just write CB is common. So this is my proof. I've shown angle, angle, side. Therefore, the 2 triangles are congruent. So the first triangle I'm going to call A, B, and C, and that is congruent to. Now, A corresponds to D. So B, I know it might sound weird, actually corresponds to C in the other triangle and C to B. And the reason is AAS. Okay? So I've shown that these 2 triangles are congruent. So that means that this angle and this angle are equal. So I'm just going to go up the top now. So therefore, angle BAC is equal to angle BDC, and that's because they are just corresponding angles, not corresponding angles of parallel lines, but of congruent triangles. A corresponds to D, those angles must be equal, okay? So I can also show that the other pair of opposite angles are equal. So if I call this X and this Y, well, this one must be X because it's equal to this one, and this one must be Y. So therefore, what I can say is angle ACD is equal to X plus Y, but that's also the same as angle ABD, which is this big one here. So therefore, I've shown that this angle and this angle are equal, and I already showed that this angle and this angle are equal. So I'm done. I've shown that in this parallelogram, opposite angles are equal, and even though it's a quadrilateral, I used triangles to prove it. There is just one more thing I need to say, and then we're done. Thank you for your attention thus far. So I'm just going to briefly go through the concept of unique triangles, and we actually use the same test. We want to test whether a triangle is unique, same test as for congruence. So remember those 4 tests that I went through before: SSS, SAS, AAS, and RHS. So the way to think about unique triangles is this. If I gave dimensions to 2 different people and asked them to draw me a triangle, would the shapes they draw be congruent? So this is the definition of unique triangles that I've given in the red text there. So basically what it means is if I give you a set of dimensions and ask you to draw a triangle, is there only one way that you could draw that? And you test for uniqueness using the same test as for congruence. So I'll give you an example. So let's say I asked you to draw me a triangle with side lengths 3 centimeters, 4 centimeters, and 5 centimeters. So I could draw one, it'd look like this. It'd actually be right angled. So I haven't drawn this to scale, but it'll look something like that. 3 centimeters, 4 centimeters, and 5 centimeters. Okay, you don't need to know why it's right angled. I'm just letting you know that. So if you were to draw one with those exact dimensions, side lengths 3 centimeters, 4 centimeters, and 5 centimeters, your triangle would be congruent to this triangle that I just drew. And that's because I've given you 3 side lengths. SSS is a test for congruence. It is a test for uniqueness. So that would be a unique triangle. A triangle with sides 3 centimeters, 4 centimeters, and 5 centimeters is unique. Anyone who draws a triangle with those dimensions, it will be congruent to my one. If I ask you, however, to draw a triangle that has 3 angles equal to 60 degrees, that's actually not unique. So hopefully you know that if a triangle has all angles equal to 60 degrees, it's equilateral. So you could draw an equilateral triangle with sides equal to 2 centimeters. You could draw an equilateral triangle with sides equal to 3 centimeters. These two shapes are not congruent because they're not the same size, even though all angles are equal to 60 degrees. Again, I didn't draw it to scale. And that's because I've given you 3 angles. Now, AAA is not a test for congruence, nor is it a test for uniqueness. That's because if 2 triangles have the same set of angles, if pair of corresponding angles are equal, it doesn't mean they'll be the same size. They may have different side lengths. And I've just shown you an example of that here. So if I ask you to draw me a triangle with 3 angles all equal to 60 degrees, there are infinitely many ways you can draw it. If you draw one, it will not necessarily be congruent to one of the ones that I have just drawn. So you just use the same test. If I give you all 3 sides, if I give you 2 sides and the angle between them, if I give you 2 angles and a side, or a right angle, hypotenuse, and side, if I give you that information, there is one and only one triangle you can draw with those measurements. Any other triangle you draw with those measurements will be congruent to the one that you draw, okay? So please, again, I've gone through this quite quickly. Let me know if there's anything I can explain better. This has been the luckiest maths teacher in the world. Have a great day.